Okay, so in this video, we're going to be talking about decimals, right? This is 1.4 from the OpenStax textbook. And we're almost through this review. We're just going to be going over decimals today, and then we're going to go over properties of real numbers in the next video after that. And then we'll get onto the Algebra 2, solving linear equations, and then quadratic equations, and all that. But right now, we're on decimals, and so we're going to be talking about what they are and how we work with them. So first question is just, what are decimals? Well, it's a very useful way of writing numbers. And it's kind of the same as fractions in some respects, except that, first of all, it is a different way of writing the fractions. And second of all, there are actually some numbers that you can't represent with a fraction, and that will be, we'll talk about that in this video. So basically, a decimal is just a way of writing fractions that have denominators with powers of 10. What I mean by that is, if we have the decimal 0.1, right, then that is equal to the fraction 1 divided by 10. Okay, if I have a 0 point, and that's kind of how we talk about decimals. We have this decimal point here, and so when we say it, we say 0.1, 0.01, etc. Anyhow, 0.01 is equal to 1 over 100, right? You can keep going. I mean, 0.001, 1 over 1,000. You can see that we're going up in powers of 10, right? And you might notice this is similar to an idea you might have learned earlier on, which is the idea of place value. So the way that the decimal system works, which is the system that we use in America, and a lot of the world uses this. Not everybody does, but the part of the way that this works is we have everything in tens, right? So we have the standard digits 0 through 9, right? And then we go up in place values of 10. So what that means is, if I have a number like 483, that means that this position of that number 3, that means the ones place, right? The ones. This 83, that's the tens place, right? And then up here, that 400 is the hundreds place. So depending on where the number is, or where the digit is in the number, you'll see different values given to it. So it's the exact same way with decimals. If we are just to the right of the decimal place here, like 0.1, then we're going to be given a value at that place of 1/10. So we call this the tenths place. And all a tenth is it's this right here, this fraction, 1 over 10, right? If we had, okay, maybe we have, here, I shouldn't have drawn that arrow there. Let's get rid of that. Okay, so if we had another number after that 1, say a 5, then now that is in the hundredths place, right? And it goes off in the exact same way, 10, 100, 1,000, 10,000, 100,000, million, etc. And so the way I think I'm going to write it here, let's just kind of break this down. If we have 483.15, then we can give each of these spots a little name, right, for how much sort of worth. So this is hundreds, then we have tens, then we have ones. Now you'll notice there's no oneths because anything divided by 1 is just itself. So the ones is kind of our center place, right? And then we go to tenths and then hundredths. And when we're working with fractions that have powers of 10 as their denominators, we can just turn if it's 100th, well, now we know that goes in the hundredths place in the decimal, right? I hope this is making sense. So one thing, let's do one more example of if I have the fraction 34 over 1,000, right? Because, just so far I've mostly been using ones on top. If I had a 34, then what that is going to mean is we're going to take, it's going to be equal to the decimal 0.034. And that's because it's the 4, the last digit is in the thousandths place, right? Because we're 1,000. And we have both that 3 and that 4 from up here. So that's how that goes. And then, and now we're going to talk about how to round these decimals, right? So, and this is kind of a idea that's more useful, I think, in a scientific context than in a mathematical context. In math, we generally consider we want to have infinite precision, but sometimes a decimal can be really long, right? In fact, sometimes it can be infinitely long. For example, the number pi, right? That's 3.1415, and it continues on forever, doesn't repeat. So in order to write it down, we have to round it at some point, right? And so what rounding is it's taking a number that has a certain amount of decimal places, and we're shortening that amount. So, for example, let's say we have this decimal 18.379. Okay, it has 3 decimal places. And actually, I should mention, it doesn't necessarily even have to be decimal places. It could actually just be the part to the left of the decimal place as well. So like this 18, we could round that to the nearest 10 or something like that. So when we're asked to round something to the nearest whatever, what we're doing is we're basically chopping everything off after that point. So if we're asked to round, so we know this is the tenths place, right? If we're asked to round to the nearest tenth, then what that's going to do is that's going to basically get rid of all this. The only thing is that we cannot just get rid of it like that. We actually we have a process that allows us to do that more accurately. And so here's how we do this. It's a pretty simple rule. Basically, if when we're rounding to a tenth or to anything, we're gonna look at the digit right after it. So in this case, it's 7. So digit after, I'll say. And we're going to check one thing. We're going to check, is it less than 5? Or is it greater than or equal to 5, right? If it's less than 5, then that means we're going to round up. And I'll explain that in a second. If it's if it's less than 5, we're rounding down. I'm confusing myself here. Okay, we're rounding down. If it's greater than or equal to 5, we're going to round up. And so what that means is this number right here, if the number after it is less than 5, then it's going to stay the same. Then this 3 will stay the same. If the 7, which this is the case in this particular case, if it's greater than or equal to 5, then we're going to round up, which means that 3 will become a 4. So if we rounded 18.379 to the nearest tenth, here's our process. we look at that digit. That's the one that we're gonna end up. That's gonna be the last digit in our answer. We're gonna look at the digit right after it, the 7, or we're gonna ask ourselves, is it greater than or equal to 5? Basically, is our question. If it's not, then we don't do anything. We just kind of scribble these out and we're done. If it is greater than or equal to 5, which in this case it is, 7 is greater than 5, right? So in that case, this 3 is just going to become a 4. So it's going to be 18.4. And you see we chop off everything else. We just ignore the rest of that number. And now we have our rounded decimal to the nearest tenth. What this means, the reason we do this is because if you ask why is it a 4 rather than just being a 3, it's because since we have this 7, 9, or really just the 7 is what matters, after the 3, it means we're actually closer to 4 than we are to 3, right? If we look at kind of like a number line sort of a thing, right? We have, let's say this is 0. Let's say this is 18.3 and this is 18.4, then 18.37 is like way over here. So if we're going to round to the closest tenth, so the closest point something, right, then it turns out we're actually closer to that than we are to the other one. So that's why we're rounding to 18.4. And I think I'm just going to give some more examples. So let's do 6.542. I'm actually going to round this to the nearest whole number. The nearest whole number, which is the 6 here. This is where the whole numbers start, right? These are the decimal places. This is the whole number places. So we're going to round this to the nearest whole number. What does that mean we're going to have to do? Well, we're going to write it out, and we're going to say, okay, that's going to be the last digit, right, in our final answer. So we're going to look at the next one, and we're going to ask ourselves again, is it greater than or equal to 5, right? Even if it's equal to 5, we're still going to round up. And it is, in this case. It's exactly 5. So we're going to round that to 7, right? Because this whole number here that we're rounding to, this 6, the number after it was greater than or equal to 5. So it means it's closer to being 7 than it is to being 6, right? And so we're going to round up to being 7 here. Okay. That's, okay. So we did rounding of decimals. Next, we're going to talk about this is kind of a tricky example of rounding decimals. This is 0.9999, and I'm going to ask you to round that to the nearest thousandth. Okay, so that's this right here. And so again, same process, right? We start and we say, okay, that's the number we're going to end with, is in the thousandths place, right? Tenths, hundredths, thousandths. So we're going to look at the number right after this guy. We're going to say, okay, is it greater than or equal to 5? Yes, it is, which means the number right here, this 9, that we're rounding to, has to go up by 1. But what happens when 9 goes up to 1? It becomes a 10, right? And so that's going to become a 0, which means we're going to have to add the 1 from the 10 to that 9, which is going to make that 9 a 10, which is going to make that a 0, and another 1, which is going to make that a 10. And you can kind of see it's going to end up like a chain reaction, kind of, right? And basically what's going to happen is it's going to keep going, add 1 to the 9, it becomes a 10, until we get to here, and we're going to add a 1 here, and that's going to become 1, and these are all going to be zeros, okay? But we're still rounding to the nearest thousandth, so we're still only going to have 3 decimal places, but they're not going to be 9s this time. They're all going to be zeros, right? So we're going to have a 1.000. And that's just a tricky thing that happens specifically with 9s. It's going to start off that kind of chain reaction. So I just wanted to cover that so that it didn't kind of surprise you when you see it at some point. Okay, so now that we can round decimals, and again, that is a very important skill, especially if you're going to be doing any science related things, physics, chemistry, any of that. It's going to require rounding a lot. And they actually have even more rules for about how you're supposed to round them and when you're supposed to round them, how much you're supposed to round them. In math, that doesn't matter quite as much. We're just kind of going to round it to whatever they tell us to round it to, right? So the nearest hundredth, nearest tenth, nearest thousandth, nearest hundred, right? Things like that. And I'm hoping you're already familiar with rounding, so I'm not going to... I might spend more time on that if it was a different situation, but this is an Algebra 2 class. This is kind of a refresher more than anything else, right? Okay, so adding and subtracting decimals, and this is specifically, for fractions, we had to worry about the denominators being the same and everything when we're adding and subtracting. Decimals aren't picky like that, so it's going to be pretty much the same as adding and subtracting regular numbers. And specifically, we're talking about adding and subtracting them without a calculator, right? If you have a calculator and you're just using a calculator to add and subtract decimals, then you type it in like any other number. You just use that decimal point, and it's going to give you the right answer. But this is specifically talking about, okay, back when you're saying, 242 plus 38, right? And you have to add it like that. This is the process that we're learning, and we're just going to add to that how we're going to do it for decimals. So for decimals, it's a simple process. First, we're going to line up the decimal points. Or let me write this down. Line up decimal points, right? 2, we're going to use zeros as padding, and then we're going to bring the decimal point down, and finally we'll just add like regular numbers, or subtract. So this will hopefully make more sense when we actually go through this process, but I'm just going to box this out and everything so that we have this fresh in our minds here. So we're going to use the example of negative 23.15. Actually, there's really another step that happens first, which is we're going to determine what the sign is going to have to be. So negative 23.5 minus 41.38, right? So this is a subtraction, not an addition so far, at least. But you'll notice we're starting with a negative number. That means we're left of 0. And then we're subtracting even more from that, which means we're going even farther to the left. So it's going to turn out that this answer is going to be negative, right? We can tell just by how it's set up. And so it might be more useful if we just wrote it like this, okay? Because like I talked about in the integers video, subtracting a positive is a positive number is the same as adding a negative number, right? So if we say negative 23.5 plus a negative 41.38, right? So this is the same thing, we just turned it into an addition rather than a subtraction, and now we're actually just going to add these two numbers, right? Because they're going in the same direction, we can just add them and then attach that negative sign at the end. So what we're going to do is, I'm just going to kind of write it like this. It's going to be a negative, and then I always like to put the bigger number on top, so 41.38, and then 23.5. So you'll notice I didn't write it back here, or that was a dumb idea. I didn't write this number over here like this over here. I wrote it over here, and the reason is, step 1, line up the decimal points, right? So these decimal points here have to be in the same place, right? Otherwise, your subtraction or addition, in this case, is not going to work. So also this minus sign over here, that's just representing that it is going to end up being negative in the end. We are doing addition, though, right now. Okay, so now we kind of set it up like this. We lined up the decimal points, right? Next, we're going to use zeros as padding. What that means is, you can see this number down here is shorter than the number on top. Well, it turns out with decimals, you can add as many zeros as you want to the end, and it won't change anything. So we're just going to add a 0 right there. So now they both have the same, they're both the same length. You cannot necessarily add zeros to the front of a number. We just don't do that. But you can always add it to the end of the decimal point. You also can't, if you have a 48, if you add a 0, now you've just made it 480, right? So that's also different. So I'm specifically saying after the decimal point, then you can add as many zeros as you want till your heart's content. So we've added our 1 0, which doesn't change anything other than just making these numbers the same length. Now we're just going to add it just like any other number, except that first we have to bring this decimal point down, right? So we're going to stick it there, and now we're going to move on with our adding, and we're literally just going to ignore it the whole time until at the very end, we're just magically going to be there, right? So 8 plus 0, that's 8. 5 plus 3, that's also 8. 1 plus 3, that is 4, and 4 plus 2 is 6. Remember, we have this negative sign here, so that's going to go there, and that's our answer, negative 64.88. So let me kind of move this. So this is, whoops, that's not what I meant to do. This is our answer right here. And so it's pretty much the same as what you would normally do in this kind of an addition. You just have to, first of all, line up the decimal point, use the zeros as padding, and then bring the decimal point down. Other than that, it works exactly like regular addition and subtraction with large numbers. I will say it is probably the most tricky part of this entire setup was the fact that, we have these negative numbers and being subtracted and things like that. And we rearranged it so it was an addition, but then we added a negative at the end. That's probably the most complicated part of this, and that is really nothing to do with decimals. That's just part of adding and subtracting when you have negative numbers. And that'll start to be more and more familiar to you as you keep on doing it. Okay. Let's now go to multiplication and division. So adding and subtracting are kind of both the same with decimals. When we're doing multiplication and division, they're going to be different, right? Because we have different ways of doing that. The multiplication rules, they're going to be kind of similar. So first we're going to line numbers up vertically. So notice we're not lining up the decimal points. We're just going to line up the numbers. Then we are going to multiply the same way we normally would. So we're going to ignore the decimal point, right? And then we just need to remember that decimal places in product are going to be the sum of the decimal places in the factor. So in product, our sum, or is, I guess, sum of places in factors. Okay. So let's just kind of go through this once. And again, the kind of first step you might want to actually do is figure out the sign of what it's going to be, because you really don't want to have to worry about that so much while you're actually doing the multiplication. So let's say we're multiplying negative 3.9 times 4.075. So kind of the first thing you're probably going to want to do is just find the sign of this, right? So we're doing multiplication and the numbers have different signs, so that means it's going to be negative, right? So the answer is going to be negative. So just keep that in mind and don't forget about it, because it's really easy to do. Then I'm just going to put the numbers in a regular multiplication setup here, right? So 4.075 times 3.9. So we've lined the numbers up so that they're both kind of on the right side. We're ignoring the decimal point. We're not lining up the decimal point like we did with addition up here, right? When we lined those up. We're not worrying about the decimal point. We're just adding those two numbers. Multiplying these two numbers. And then we're just going to multiply and ignore the decimal points. So pretty much for multiplication, you get to ignore the decimal points until the very end. So 9 times 5 is 45, put the 4. 9 times 7, 63, add the 4. So that's going to be 67, carry the 6. 9 times 0 is 0, add the 6. 9 times 4 is 36, so that's our first one. Okay, then we're going to do our 0 here, just like we normally would, and then the 3 times the 5 is 15. I'm going to erase these guys now up here so we can... Okay, 3 times 5 is 15. We're going to put the 1 here. 3 times 7, 21. Add the 1 to get the 22. 3 times 0 is 0, and then we're going to add the 2. And then 3 times 4 is 12. We're going to add these. So 5 plus 0 is 5. 7 plus 5 is 12. Carry the 1. 6 plus 1 is 7. Plus 2 is 9. 6 plus 2 is 8. 3 plus 2 is 5. And 1 is just 1. Now that we're at the very end, right, we've done step 2, multiply, right? Now step 3 is just the decimal places in this product right here are going to be the same as the sum of the places in these two factors. So how many decimal places are in 4.075? That's 1, 2, 3. And in 3.9, that's 1. So 3 plus 1 is 4. So basically 1, 2, 3, 4. Then we're going to come over here and we're going to go 1, 2, 3, 4. And put the decimal place right there. So now our answer is going to be 15.8925 with this negative sign that we carried down all the way from up there. Don't forget that negative sign. And so now this is our answer. We've learned how to do multiplication with the decimal points. Now we can move on to division, which is going to be a little bit different. So for the multiplication, it's pretty much the same. The only thing you have to always remember to do is use those decimal points, right? And again, it's just going to be the sum of however many were in this product. So in this case, 1, 2, 3, and then 4. We add those up and put them in. For division is a little more of a process, I feel like. We're going to be using this kind of long division box system that we use for long division. And we're going to, first we're going to refresh kind of in our minds the idea of division having a dividend, a divisor, and a quotient. So when we move that into the box setup, what that's going to end up being is the dividend goes in here, the divisor goes in here, and the quotient goes up here. So in division with decimals, it's going to be exactly the same. And I'm just going to kind of go through it while using an example. So negative 25.65 divided by negative 0.06. Okay, so just to label some things, that's the dividend, that's the divisor, and we're going to find the quotient. That's our goal. So we're going to put it in a box setup, right? So these negative signs, we really, you don't want to have those while you're doing the division. So we'll figure it out beforehand, and it turns out that because we have these two negative signs and we're doing division, they'll cancel each other out. So the answer is going to be positive. So we're going to put the divisor out here, 0.06, and then the dividend in here, 25.65. And then what we're going to do, this is kind of the weird thing you do with division for decimals. We're going to take this decimal point over here in 0.06, and we're going to move it over as far as we need until it's at the end of that number, right? And you're going to count how many times you had to move it, right? That was 1 and 2. And we're going to move it the same number of times in the dividend. So 1, 2. Not necessarily to the end. Some numbers it won't be to the end. So just do it the same amount as you did with the divisor. Then we're going to take that decimal point and we're just going to make it in the same place up here for the quotient. Now we can kind of start just doing this normally, but basically what we've simplified this down to is 6 going into 2565 point, and then we'll go on. So how many times does 6 go into 25? And again, this is just going to be, it's going to be pretty much like regular long division. So 6 goes into 25 4 times. 6 times 4 is 24. We subtract, we get the 1. We're going to bring down the 6. 6 goes into 16 2 times. 6 times 2 is 12. 16 minus 12 is 4. We're going to bring down a 5. 6 goes into 45 7 times, because 6 times 7 is 42. So we're going to put the 7 there. And 6 times 7 is 42. We're going to subtract, we're going to get 3. And normally with division, that would be your remainder, right? But when we're doing it with decimals, we can actually, if you remember, we can just add as many zeros as we want on the end here. So we're just going to add a 0 there and bring that down. So now it's 30, and 6 goes into 35 times. 6 times 5 is 30, and now that's going to be 0. So the answer then would be this right here, 427.5. And it turns out that, I mean, again, this is pretty much the same as regular long division. The only two differences are that weird thing we did in the beginning, which was taking 0.06 and moving that decimal place, moving this the same number of times, and then bringing that decimal point up there. That's the first weird thing you do. The second weird thing or different thing you do is you can add these zeros at the end, right? Whenever you need them. Now, sometimes you will get stuck in repeating decimal kind of a situation, right? So you might say 10 divided by 3, and you'll notice we're not even dividing decimals here. These are just whole numbers, right? 10 divided by 3. So we're gonna say, okay, 3, 10, and you can use that decimal point thing here whenever you need to, even when you're just dividing regular numbers, because sometimes when you divide regular numbers, you'll still end up with a decimal. So if 3 goes into 10 3 times, that'll make 9. We subtract, we get 1. If we say this is the same as 10.0, we can bring down that 0. 3 goes into 10, right? It's the same thing again, so it'll be, and whenever you put that decimal point there, you have to put it up here also. 3 goes into 10 3 more times, makes another 9, makes another 1, we can put another 0, and you can see this is going to end up being 3's forever, right? Which is, so sometimes this 0 is going to help us out and get us to an answer, sometimes it's not. And in that case, if it keeps on repeating something like this, then we just write it with this bar over it. That just means that the 3 repeats forever. Okay, that's dividing. Next, we're going to talk about converting. So we have a bunch of different ways of writing these kinds of numbers, right? We have fractions, we have decimals, and then the third one we're going to talk about is percents. But we need to be able to convert between all of these. So we need to make a fraction be a decimal, or a decimal become a fraction, or a percent, or all these different things. We just need to be comfortable changing between these. So the first thing we're going to want to know, how do we go from decimals to fractions? And sort of the key to this is what I was talking about in the very beginning of the video, which is that decimals are really just fractions with powers of 10 on the bottom, right? So what we're going to do, let's get a number ready. 0.374 is our decimal. And we're going to find the place value of the very last digit, right? And that is a 4. And that's really, you're going to want to find the place value of the last non-zero digit, right? So if we just have a bunch of zeros over here, again, those kind of are invisible to us. We don't really care about them. So we're looking at the last non-zero digit, and we're looking at what place that's in. So if we start over here, that's the tenths, the hundredths, and the thousandths. So that's the thousandths place. And so that is going to be the number that you're going to put in the denominator, right? So if this is the thousandths, then that means we're going to, in the denominator of our fraction, we're going to put 1,000, right? Because 1 over 1,000 is 1,000th. And then on top, we're just going to put all the non-zero numbers, right, up here. So this is 374 thousandths. If there were zeros in front of this, we would just ignore those again. And if there were zeros behind it, we'd also ignore them. So if there were zeros in between, we'd keep those. So if it was 3704, then we'd do that, right? But in this case, we didn't have any zeros to worry about, so it's just 37.4 over 1,000. So that's pretty simple, converting from decimals to fractions. Let's do another one. Let's do 0.02050, just so we can kind of get more practice, and I'm specifically using all these zeros so that we can see how these factor into this. So we're going to find the first non-zero digit, the last non-zero digit, which is 5 here, right? Because after that it's just 0. And we're going to figure out what place that's in. So we start here, that's the tenths, hundredths, thousandths, 10,000ths. So that's what's going to go on the bottom of the fraction, 10,000. And then up on the top, we're just going to take this number right here, right? We're going to ignore the zeros before and ignore the zeros behind, but we're going to keep that 0 in the middle. And so we're just going to get 205 over 10,000. And that doesn't necessarily mean these are simplified fractions either, because as you can see, both of these numbers are divisible by 5, so you could simplify that, but we're not worrying about that at the moment. Okay, so if we know how to convert from decimals to fractions, how do we go from fractions to decimals? And it turns out that's even easier as far as the number of steps you have to do. To go from a fraction to a decimal, you actually just divide the fraction. So if I say, no, that's not a good example. 5/8 or negative 5/8, just use a negative sign. All we do is we take that fraction and we're just going to do a long division with it. So 8, 5, and I'm just going to hint that we're probably going to need this decimal place here. And we'll just divide it. So 5 goes into 8 one time. 5 times 1 is 5. 8 minus 5 is 3. We're going to put a 0 here, bring that down. 5 goes into 36 times. 5 times 6 is 30. And now we're at 0. So the answer to that is 1.6. We had the negative sign, so negative 1.6 is that fraction as a decimal, right? We've converted the fraction into a decimal. So fractions are super easy. You just take the division and go through it, and it comes out nice for you. Okay, so percent are an interesting thing. So, you know, if we have like 25%, or 75%, or anything like that, the really important thing to realize about percent is just that all a percent is a number divided by 100, or a number out of 100, right? So it's, when we say 25%, that means 25 out of 100. And actually the word percent means per 100. And per means divided by, right? So to take a percent and turn it into a fraction is very easy. All you do is you take that number, right? 25, for example. So 25%, we just take that number and we put it on top of the fraction, and then on the bottom we put 100. That's all you have to do to turn a percent into a fraction. To turn a percent into a decimal is slightly more involved, but it's still very simple. All you're going to have to do, so again, let's use 25%, is you're going to move the decimal point 2 spots to the left. So if you think of this as being the same thing as 25.0%, for example, because remember, those zeros after a decimal place don't change the number at all. All we're going to do is we're going to move that 2 spaces to the left. So that's going to be 0.25, and then we're not going to write this percent anymore. So 25% is the same as 0.25 as a decimal. And if we want to go from a decimal back to a percent, it's the same but opposite, right? You're going to move that 2 spaces to the right, and then add that percent sign on the end. And so if we have 0.25, right, we move that 2 spots to the right, we're going to get 25%. So that's how easy it is to use percent, right? It's a lot harder to, or the percent is much simpler than using going from fractions to decimals, or decimals to fractions. Those are fairly easy, but the percent is really easy, especially with that fraction. You just put it on the top and divide by 100. So now, I'm just labeling this, almost there. Now we're going to talk about what happens now that we've talked about fractions and decimals. What does that mean for the numbers we work with, right? Because if in the integers video, we talked about how we have the natural numbers, right? That was 1, 2, 3, ... right? The counting numbers. And we then talked about having the whole numbers, right? Which started with 0 and otherwise was the same. Then we added the integers, right? Because we had the negative numbers. So what happens when we have numbers in between 1, 2, and 3, right? What happens when you have that? Well, what we're going to get is what we call the, well, okay, if we just add fractions, let's not worry about decimals yet. If we just add fractions, we're going to get what we call the rational numbers. So the rational numbers, the reason we call them rational is because of that word ratio, which basically just means a fraction. Any number is rational if it can be written as P over Q, where P and Q are integers, right? And Q is not equal to 0. So that is going to be any fractions that you come across, as long as it's, you can't have like a complex fraction. And you also, and the reason is because then the P and Q wouldn't be integers, they'd be fractions, right? You also couldn't have like a fraction with a decimal on top and bottom. But where P and Q are integers and Q is not equal to 0, this is basically any number that you can turn into a fraction is rational, right? And so first of all, let's realize that the integers are included in this, right? Because let's say, and we talked about this in the fractions video, let's say we have the number 3, well, it can be written as 3 over 1, right? So that means it satisfies that, which means it's a rational number. But that also includes a number like 2/3, right? Where P is an integer, Q is an integer, and neither of them are 0 in this case. And so that is a rational number. Even though it doesn't actually evaluate to like a specific integer, it's actually decimal, right? It's 0.666666 with a bar. So that's the rational numbers, and that expands our numbers that we can use by a lot. Now if we add in decimals, some of the decimals were already added in when we added in fractions, right? Because, this 2 divided by 3, that turns into a decimal. So that decimal is part of the rational numbers. But there are some decimals that don't fit into the rational numbers. For example, the number pi, right? That is 3.14159265 And the thing that's special about pi is that these numbers don't repeat and they go on forever. What that means is we can't write it as a fraction. And so this belongs to a set of numbers called the irrational numbers. Very creative naming, right? So because we can't make a ratio out of it, we call it an irrational number. Let me fix that now. So that includes numbers like pi. It also includes numbers, some square root numbers, like the square root of 2. They all kind of fall into these irrational numbers category. So now if we take the rational numbers and the irrational numbers and put them together, so you kind of think of it as rational plus irrational, we're going to get one of the most important sets of numbers in math, which we call, I'm even going to write it in red, the real numbers. And that sounds all crazy because aren't all numbers real? Well, it turns out not all numbers are real. But that's, so the real numbers are the combination of the rational numbers with the irrational numbers. And that's probably what we're going to be using most of the time when we're talking about different equations and things. It turns out there's actually another set of numbers called the imaginary numbers, and those are numbers that they don't exist, and that's really interesting too, which it will be covered later on in Algebra 2 a little bit. As kind of a preview, you could think, okay, well, what's the square root of -1, for example, right? That's actually a very important number in the imaginary world, because you can't take a square root of a negative, because nothing times itself is going to be negative. But I am digressing. If we have these real numbers, and again, the way we got to that is by getting the rational numbers, and we got those by adding fractions to the integers, kind of. And then the irrational numbers we got by adding decimals, right? And so when we put all those together, we get the real numbers, which are what we're going to be working with most of the time. So now that we have all these numbers, it's useful to know how to kind of put them on a number line, right? No, that messed up my arrow there. If we have our number line and we start at 0, right, we're comfortable plotting, the number 1 on here, right? That's pretty easy. But what if we wanted to plot the number, a fraction? So what if we wanted to plot 1/5? Like, where would that go on this number line? And the way we plot this is if we look at this denominator here, we're going to split this distance between 0 and 1. 1/5 is between 0 and 1, right? Somewhere between. We're going to split that distance between 0 and 1 into 5 parts. So 1, 2, 3, 4, 5. You can count those spaces. And we're going to go one of those fifths, right? So this one right here, let me do that in blue actually. That right there would be where 1/5 goes, because it's one of the fifths that get to 1, right? So sometimes you'll have a fraction, and we call these improper fractions. For example, -9/2. And you'll see that it's actually greater than 1, right? That would go past 1 by some amount. And the way we figure these out is we turn it into a mixed number. And I'm just going to assume that you're already comfortable doing that. So -4.5 is what this 9/2 is equal to. So then what we're going to do is we're going to start by going the number of places of the whole number, right? So -1, -2, -3, -4. So we start with -4. -5 is out here. Then we're going to go 1/2 of the distance. So if we split that distance between -4 and -5 into 2, we're going to go 1/2, which happens to be right there. And that's where -9/2 is going to be. So fractions aren't too bad. Decimals aren't terrible either. They're a little bit harder to write out because they like the number 10 so much. If we have a decimal and we're wanting to go, let's say we're going to want to put the number 0.4 on here. Well, if we look, 0.4 is going to be between 0 and 1. And with a decimal, this number in front of the decimal point, in this case it's 0, that's going to tell us where we're going to start from, which is 0 in this case. These are going to tell us how far we're going to go after that. So the numbers before the decimal point tell us where to start. Numbers after tell us where we're ending, kind of. So if we start at 0, and now we're going to take the distance between 0 and 1, and we're going to split it into 10 equal parts, if I can do that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's pretty good. And it tells us, okay, we're going to go 4/10, right? That's what that means. So we're going to go 1, 2, 1, 2, 3, 4, right here. That's where 0.4 is going to be. If we have a number that has more decimal places than that, then it gets, a little trickier, but I'll do my best here. So let's say I'm going to put 0 way back here for this one. Let's say we have the decimal 1.53. I'm going to put 1 here. I'm going to put 2 here. So we start with that number in front. We're going to go to 1 here. And then we're going to go to this number and we're going to say, okay, that's how far we're going after 1. So first, let's actually start with the 5. Because we're just going to kind of go from left to right with these digits. So if we start with 5, let's divide this space up into 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we go 5 of those spaces, we'll see 1, 2, 3, 4, 5. And see, I did not even give myself enough room, even with all that. Actually, let's do that in green. 1, 2, 3, 4, 5. So that's 1.5, but then we have this 3, so what we'd have to do is split this distance from 0.5 to 0.6 into another 10 little spots here. So that'll be, let's do yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And then we would go 3 of those. So 1, 2, 3, it'd be kind of right over there. And when you get to decimals like that, it's always gonna be an estimation. But at least you kind of know the process of how we plot these. Okay, and then the very last thing that I'm going to go over is kind of a random thing that they put in the textbook about square roots in this chapter. I don't know why they're talking about square roots in this chapter. They kind of just put it in the middle of it, but it was in the textbook, so I'm gonna do it anyways. When we talk about the square root of a number, what we mean is, so if we say the square root of 4, what that means is what number multiplied by itself one time is going to equal 4, right? So in other words, what is a number such that we can say x times x equals that number n, we'll say. So what is x in that case? Let me write it like this. If we take the square root of 4, that is the same kind of a thing as saying, what is x such that x times x is equal to 4, right? That's what taking a square root means. And so in this case, of course, it's 2. 2 times 2 is 4. But it turns out with a square root, which isn't actually denoted by that symbol, it's plus or minus square root 4, there's actually 2 different answers that we have to this. So the first answer is, of course, 2, right here. The second answer is negative 2, because if we multiply negative 2 times negative 2, we're still going to get 4 because those negatives cancel. So when we have a square root, we need to be mindful that we actually have 2 answers. We have the positive one and the negative one. And if we ignore that, then we might miss a possible answer to our solution. And that'll be really important when we get into quadratic equations. And you'll see that there's some equations that have multiple solutions, and it's really stemming from this idea of a square root having a positive and a negative result. So because of this, we kind of have a special way of writing, when we write a radical sign like that, that's called the radical symbol. This means the positive answer. So it's always going to mean the positive one, which is 2 in this case. And so we call this the principal square root. And just think principal positive, right? That is all that you need to know at this point about square roots in that section. They just wanted to make sure that you knew that at this point. So when you have a square root that doesn't have this kind of plus or minus thing over here, that just means, so okay, when it comes without that plus or minus, that means it's the principal square root rather than the regular square root. So that's all for that video on decimals and apparently square roots. In the next video, it's going to be about properties of real numbers. And yeah, I'll see you there.